So I don't know what happened there, but like my Apple screen just showed like the Apple symbol. It seemed like it closed. Thanks, Zenfeng. Show. So let me share screen. Okay. So let's go Zoom. Something's Zoom. Notability. Okay. So Math 140B. Okay, so today will be FTC and improper integrals. So we define functions. Integral of functions on AB. And so what if H is defined on, say, open interval AB, right? What do we mean by integral of H? So we say, what if it's here? So we say H is integrable if on AB, on open interval AB, if every extension of H to, close interval AB is integrable. So no, extension just means define H of A as something, define H of B as something, right? And then that function is integrable. So normally this is the case, right? Because I mean, especially for like continuous things, right? Like I guess things that don't behave like 1 over x, things that don't blow up in general, it will become integrable. So the reason for that is adding a point shouldn't really affect the area under the curve, right? I mean, unless you're heading off to infinity, like 1 over x, and you just add in 0. So yeah, okay. So we have FTC1. So we have g as a continuous function on AB that is differentiable on open interval AB on open interval AB, and g prime is integrable on AB. Then integral AB g prime is g of B minus g of A. So hopefully this is clear, right? You could think of integral as antiderivative. So if you antiderivative the derivative, you should just get something related to your original function. So that should be clear. So integration by parts. Does anyone know like why we do this, or how this came about? So anyone who's here? Yeah, it's product rules. So it's based off the fact that integral fg is not integral f integral g, right? Because if this was the case, we don't need u sub, we don't need anything. We just split everything up and integrate, right? And part of it is because the derivative is not this, right? So the antiderivative will not be that. So this is sort of like product rule for integration. So we have if uv, that's a v. So if uv continuous functions on AB that are differentiable on open interval AB, And if u prime, v prime are integrable on AB, then this is just product rule. So u of x, v prime of x dx plus integral AB u prime of x, v of x dx is u of b, v of b minus u of a. So most people is used to, you know, this term being on the other side. So, but it is integration by parts. Okay, so right now, the top FTC1 was antiderivative of derivative. So you could guess what FTC2 is. It's derivative of antiderivative. So FTC2, it's the opposite, right? Let f be integrable function on AB for x in AB. We let f of x be the antiderivative. So this is not a function of t. Yeah, this is a function of x. So if I plug in like f of 2, capital F of 2 is integral a to 2 f of t dt. Then f is continuous on AB. And if f is continuous at x naught in AB, then f is differentiable at x naught. And you could pretty much guess what it is. Again, derivative of antiderivative should cancel out, right? So f prime of x naught is, I do d dx of this thing, right? And evaluate at x naught, right? If you think about it, derivative of if I take antiderivative of f and then derivative of it, I should get back f, right? And then if I evaluate at x naught, I should get f of x naught. So FTC is just saying antiderivative and derivative. The word anti is justified. So nothing too much there. Okay, so yeah, okay, so we have stuff called u sub. They don't call it u sub, they call it change of variable. And this should be the last thing. So let u be differentiable function on open interval J such that u prime is continuous. I is an open interval. So this is just setting it up so like our domains, you know, is integrable, right? Or the image of the map from u of x, right? Because we're sort of moving from like x coordinates to u coordinates, I guess. So if f is continuous on I, then f compose u is continuous on J, and we have this natural formula, right? So this is your typical U sub, right? And the reason we have the I and the capital I and capital J is because our bounds change, right? We're pretty much on a different, you know, we're integrating from like domain to like image for A, B, and J. Okay, everyone good? So this is just review of calculus. So if not, I can move on. So let's go to questions. So Kenneth Ross. Let me move back up. Riemann integral. All right, should be here. Yes. Okay, so let's start doing questions. So 34.2, calculate this limit. So calculate limit x goes to 0, 1 over x, integral 0 to x, e to the t squared dt. So how are we going to calculate this? What theorem should I use? Anyone? So what does this thing look like? Let me just ask. What theorem had something like the blue underline? Let me make it blue. What theorem had something like this in it? Like integral 0 to like a number to a variable. So, well, yeah, part 2, right? So what does part 2 say? Part 2 says if I take derivative, I just evaluate, right? So you might wonder, maybe this is the derivative. Because if you remember, if I call this thing f of, the blue underline, f of x, what is the f prime at 0? This is limit x goes to 0, f of x minus f of 0 over x minus 0, right? Okay, well, f of x was just this thing, right? And I have over x, but what is f of 0? I mean, capital F of 0. What is it? So, can anyone tell me? So what is, I need to subtract capital F of 0, right? So I'm pretty much asking, what is this thing? Anyone? Yeah, it's 0. But what? So the reason is, f of 0 is integral 0 to 0, right? I'm plugging in 0 for x. I mean, this is just 0, right? Because I don't care how big e to the t squared is, right? If you do your Riemann sums, right, your rectangle has like no width, right? Because you're only integrating over a point. I mean, and area of rectangle is length times width. So if you have no width, it should be 0, right? So you get, so you see, it's exactly just this, right? It's exactly just the thing, the question's asking. So all it's asking for is f prime at 0. But so what does FTC say though? What is f prime at 0? Right? Again, this is ddx of f of x, which is, evaluated at 0, right? What is that? So FTC2. Yeah, it's 1, right? So this is 1, and then you're done. So just application of FTC. Part B is the same, right? So you have, what is part B? Limit h goes to 0. So this is using the other definition of limit, right? Integral 3 to 3 plus h e to the t squared dt. So again, if I let, let me think. So if I let f of x be integral 3 to x, e to the t squared dt. Then f prime at 3, you could go extra, but there's a separate limit definition, right? It's given by this, right? It's f of 3 plus h minus f of 3 over, if you like, the difference of the 2, right? Which is just h, if you like. So I'm just going to write h, right? And again, f of 3 is 0, right? So what you're going to see is you get exactly this, the thing they're asking. So 3 to 3 plus h e to the t squared dt. So f prime at 3 is just d dx of integral 3 to x e to the t squared dt, evaluated at 3, right? So what is this? So it should be, you just plug in 3, right? So it should be e to the 9, right? E to the 3 squared. Okay, is everyone clear on how FTC2 works? So of course, like if you can integrate it, like you can do so. What I mean is the point is this thing is actually hard to integrate, right? So you see, like I don't even need to know how to integrate e to the t squared to find the derivative. That's kind of strong, right? Of course, if you can integrate it, then it's the same, right? Like if you have integral 0 to x t dt, then is f of x. So f prime at x by ftc2 is just x, right? I plug in x for t. But you could have just used ftc1 and say this is, ftc1, this is t squared over 2, evaluate, so f of x is, sorry, any space. F of x is t squared over 2, evaluated at 0 and x. So f of x is x squared over 2, right? Minus 0, right? And then f prime of x is just derivative of x squared over 2, which is x, right? So you could have done it either way, right? But you see, this is, FTC2 is powerful in the sense that even if you don't know how to integrate this thing, you can still find the derivative. So, but if you knew the antiderivative, then it's the same. Okay, is everyone clear on this? Good, okay. So let's do 34.3. So we have that f of x, okay, take it back. I need to define what f of t is. So f of t is less than 0 for t less than 0. It's a line for 0 between t between 1, and it's 4 for t bigger than 1, right? So let me just write this more nicer. So f of t is 0 for t less than 0, t for 0 less than or equal to t less than or equal to 1, and 4 for t bigger than 1, right? So the question is asking, determine f of x, which is integral 0 to x, f of t dt. Right, so let's split this to cases, right? Hopefully you all can do calculus. So what is this equal to if x is less than or equal to 0? What is this? So FTC1. So I'm integrating from 0 to x. In other words, you can think of it like negative of integral x to 0. Right? So, I mean, x is just some negative number. So if you like, since we normally order it the other way, this is negative x to 0, right? And I'm integrating from like a negative number or 0 to 0. So I'm in this range, right? So I'm just integrating the 0 function, right? So it should be 0 for x less than or equal to 0. Now, what about between 0 and 1? So now x is, this actually is ordered now. And for between 0 to 1, it's just the function t, right? dt. It's just integral 0 to x t dt, right? Because we lie here. And this is t squared over 2 evaluated at 0 and x. So it's x squared over 2, right? So it's x squared over 2. And what about x bigger than 1? So if x is bigger than 1, we're in two places, right? We are here and we are here, right? So we need to split this up, right? So integral 0 to x f of t dt. So on one hand, it's t up to 1, right? T dt. And then from 1 to x, right? It's from 1 to x, it's 4. So it's like this. So you see here that this, hopefully you could all do this. The t squared over 2 evaluate 0 and 1 plus 4t evaluate at 1 and x. So I think it's a half plus 4x minus 4. So it should be a 4x minus 7 over 2. If I did this correctly. If I did the algebra wrong, please tell me. Pretty bad at algebra. So it's 4x minus 7 over 2, right? Everyone clear? Great. So now the question is, where is f continuous and where is f differentiable? So where is f continuous? Well, certainly on, outside the borders, 0 and 1, each function is continuous, right? 0 is a continuous function, x squared is a continuous function, and 4x minus 7 over 2 is just a line, right? That's also continuous. So to check continuity you just need to check it doesn't jump at the border, right? At like 0 and 1. So to check it doesn't jump, just plug in 0, right? So at 0, this is 0. At 0, right? So let me just use green. At 0 from like the left, it's 0. At 0 from the right, it's still 0 because 0 squared over 2 is 0. So it's continuous at 0. Let's check 1. So at 1, this is 1 squared over 2, which is a half. And at 1, this is, if it's a half, 4 minus 7 over 2. Yeah, that's a half. So it's actually continuous everywhere. So everywhere. Right? Now, where is f differentiable? So again, it's certainly, outside the border, 0 and 1, it's clearly differentiable, right? The derivative of 0 is 0. Derivative of x squared over 2 is 2x. And derivative of 4x minus 7 over 2 is 4, right? So we only need to check whether it's differentiable at 0 or at 1, right? So let's check at 0. So how do I check? So I need to check limit x goes to 0, f of x minus f of 0 over x, right, exists, right? So let's check the limit from the right. So if I go from the right, what do I have? So if I go from the right, f of 0 is 0, right? Because I have equality here, right? Equality. So that's nice. But if I go from the right, I'm bigger than 0, right? So I should have that. Yeah, I don't know why sorry, this should be less than. I don't know why I didn't. Yeah. But either way, in this case, at 0, it's 0, because 0 squared over 2. So here, you get that if I approach from the right, I'm taking values bigger than 0. So my f of x is x squared over 2. So I have x squared over 2 minus f of 0 is 0 over x. And what is this limit? It's x over 2, right? So it's 0. And it's clear that if I take limit from the right, I'm taking values less than 0. So my f of x is just 0. So I just have 0 minus 0 over x, which is 0. So the left and right limits agree, right? So it's differentiable at 0. So now let's check at 1, right? So I need to check whether this limit exists. Minus f of 1 over x minus 1, right? So again, let's do 1 from the right. So if I take this limit from the right, I'm taking values bigger than 1. And if I'm bigger than 1, I am 4x minus 7 over 2, right? So 4x minus 7 over 2. And I'm subtracting, what is f of 1? So I have equality, equality right here, right? Right here. So at 1, if I plug in 1, it's 1 squared over 2, which is a half, right? Over x minus 1, I need limit. X goes to 1 plus. This becomes 4 times x minus 1, right? Because 8 over 2 is 4, and then x minus 1. So this limit is 4. On the other hand, if I take limit from the right, what do I get? So obviously that the f of 1 is still half. If I take it from the right, I'm using x squared over 2, right? So minus a half over x minus 1. So this is really just 1. If I pull the 1/2 out, it's x squared minus 1 over x minus 1, right? So this becomes x plus 1. And if I plug in 1, I should just get 1, right? And you see that these two are not equal, right? So not differentiable at 1. So the answer is differentiable everywhere. Differentiable everywhere, but at 1. But okay, is everyone clear on this? So we're using FTC 1 here. So okay. So if you need practice, do 34. It's like a repeat. So we have f continuous, and we need to show g is differentiable and compute g prime. So I'm gonna, yeah, so this is not that bad. So continuous function. G of x is integral sine x. Is it 0? 0 f of t dt. So basically, show what g prime is. So FTC2, you know, if I go all the way back, FTC2, I can almost use it, except there's an x here, right? So the problem is I have a sine x. So what I can do is say, let f of x be what I want, like just the x on top, right? So I could use FTC part 2, and then let h of x be sine x. Then what can you tell me about this? What is the composition? Yeah, it's just g, right? It's exactly integral 0 to sine x f of t dt, right? It's g of x. So I want to find derivative of g, right? So in other words, ddx of f of h of x is just ddx of this, right? If it exists. So a priori, we don't know it exists. But what does this tell me? This thing is just chain rule, right? Hopefully, I trust you all remember chain rule. It's this times h prime of x, right? So to find f prime of h of x, let's find f prime of x first. So what is f prime of x? That's when we can use FTC part 2, right? Because I want f prime, but f prime is what we want. It has the x on top instead of the sine x. So f prime of x is just f of x, right? I just plug in the x by FTC part 2. So what is f prime of h of x? I plug in h of x for x, right? Which is h of x is sine x, so f of sine x, right? And then I multiply by h prime of x, which is cosine of x. So your answer is this, right? Plug in and multiply by derivative. Right, so it's differentiable because, I mean, these two are clearly differentiable, and it's given by a product of them. So, okay. Any questions so far? So I want to maybe just do one more, yeah, and then I'll move on. So let's pick something harder. Let's do 34.10, yeah. So g strictly increasing continuous function. G strictly increasing continuous function from 0, 1 to 0, 1. Give geometric argument. Showing integral 0 to 1 g of x dx plus integral 0 to 1 g inverse of u du is 1. Can anyone explain this, or? So what? Okay, let me just draw g, right? I mean, g is strictly increasing. So I mean, here's 0, here's 1, and here's 1, right? I'm mapping 0, the square, right? 0, 1 to 0. So I'm like in this square, right? I'm in 0, 1 cross 0, 1. And g is strictly increasing. Let's say, voila. Okay, what's integral of g? Can anyone tell me? Or what should I shade in for integral of g? What area am I finding? Yeah, below, right? It's this thing. Right, this thing will give me this. Okay, now let's, obviously, you can see the G inverse should give the other side, but let's see why. So remind me, what does inverse do? So if G takes 0 to like 1, for example, then G inverse takes 1 to 0, right? So we swap x and y, right? So you sort of see, what is this integral? Well, it's just the integral of if you just tilt your head. If your y-axis is now the x-axis, so like if you tilt your head and view this as your x-axis, right? And then like the other one as your y-axis, sort of, right? You're gonna get the area under the curve is like this part. So it's a bit, hopefully you can convince yourself of that, right? Because you're swapping x and y. So now you're pretty much finding, area under like the curve given by, I guess to be precise, I need to shade it this way, right? Area. So, and then here, I mean, this is just the area of the square, which is 1 times 1. So, everyone good? I mean, it's just geometric argument. I'm pretty sure that's good enough of an answer. So, okay. So let me just go over improper integrals really quick. So, and then we can go. So, B, so we're on interval A to B. So B finite or positive infinity. So F defined on A to D for all A less than D less than B, right? So again, this is this open part, right? So just like before, I think I mentioned this earlier, right? What if we're defined on open interval AB? Then we sort of extend it, right? So you can sort of think like we take all the limit. So in general, it's like taking the limit as you go to B. So suppose limit D goes to B from the left. Now, why from the left? Because I'm only defined, I'm defined like here, right? If I take D approaching B from the right, I don't know if I'm defined for values bigger than B, right? I mean, but I am defined for values less than B. So that's why I'm approaching from the left. So from here, it's A to D, f of x dx. And let's assume it exists. By exists, I guess the book in this case takes it to be finite, positive infinity or negative infinity. Then, then define what is integral A to B, f of x dx. It's given by limit D goes to B minus A to D f of x dx. So if B is finite and f integrable on AB, this is just usual definition. So I mean, some people do call it improper, but it coincides with the proper one. So, and then if B is positive infinity or f is not integrable on AB, but limit exists. So here by limit exists, it's okay to be, infinite. Then we say that integral is improper. Is improper. So let me just go over the important parts. So really, the common mistake people make is if it's improper on both sides. So example would be integral negative infinity to infinity f of t dt. Right. What you need to do is do this. Is pick a point where it is defined, you know, where f is actually defined. And then you go, like if it's defined at 1, for example, then you do this. And of course, the limit, you know, is undefined if you have like infinity minus infinity or so and so on and so forth. And you know, it exists if, you know, each of these exists. So why is this important? Because some people do this. Right? And this is not the case. So it's not true that these two are equal. So examples are like, you know, f of t is, I think the famous example is sine. So if you use the other way, like sine keeps oscillating, right? It's pretty clear these limits don't exist, right? If you try to evaluate it, because sine just keeps oscillating. So you're never gonna approach a certain area, right? But here, if you did this, this is just 0. Because if you go from A to A, sine is just an odd function. So like, you know, the areas will cancel out. So if you go from like A to A, right, this area will cancel this area, so on and so forth. So I guess the important thing I want to ask you all is, just so you're all, you know, clear on this, why is this not correct? You know, why do we have to split it into 2? Can anyone give me a, you know, intuitive reason why the middle part is not true? I mean, I mean, it cancel is not an issue, right? I mean, if it's undefined from negative A to A, I mean, even this thing is an issue, right? If you're undefined, you're clearly undefined here too. So that is not the issue. I mean, if that was an issue, then your integral doesn't even make sense, right? F should be defined on negative infinity to infinity. So let me ask you, it's the idea that here you are going to infinity and negative infinity at the same rate. You're going like, you know, for example, just to convince you, like 1 over n goes to 0, but 1 over n squared also goes to 0, right? But they go to 0 at different rates. And if you remember, sort of like the definition of limit, if limit goes to a, if and only if for every sequence going to it, it works, right? So basically, I'm basically saying you don't have to choose sequences where, you know, they go to infinity and negative infinity at the same rate, right? It could be you go to infinity faster and then negative infinity slower. So that's sort of the reason why, you know, you need these two, because this thing only considers the case where you're sort of going to infinity and negative infinity at the same rate, right? But it could be like one of them goes like n, like limit n goes to infinity of n, but the other one goes to infinity like n squared or something. So remember, so for limit, you need to consider like all possible ways you go to something, right? And part of the issue is you can go to infinity and negative infinity at different rates. So hopefully that's clear. I think that's the most important. Other than that, it's just calculus. I trust you can all do calculus. So again, so maybe I'll just make Wednesday office hours since there's no quiz. And so good luck on your midterm, and thank you for coming if you're not coming again. So and make sure to do your evals.